topic is ionization constant of acid or base. So suppose we are taking as a weak acid. For weak acid, suppose this is HA, we want to dissociate into H plus A minus. So if it's like the K equilibrium, will be we know that concentration of product by concentrations of reactants. And for acids, K equilibrium equal to we as Ka. So this is for weak acids, and for strong acid if we say for strong acid, like if we say HCl, then this is completely dissociate. So suppose this is 1 molar, then 0 0, T equal to 0, and T equal to T equilibrium. This is fully conjugate and 1 H4. So for strong acids, this Ka value is very large. So we generally not taking for strong acid. So for weak acids, yes. So for weak acids, so Ka is H plus A minus HA. So if you notice that Ka is directly proportional to concentration of H plus. So if H plus concentrations is increases, then Ka value will be high, means more acidic. So Ka value is more, means H concentration is more, means more acidic. Let us say as example, if Ka value is given, suppose CH3COOH, this value is suppose 4.9 into okay, this is 1.7 into 10 raised to minus 5. I am taking approx. Exact value we can, just for understanding, I am taking the approx value. And for suppose HCN, this value is 4.9 into 10 raised to minus 10 approx. Then what happens? So ask that which compare the strength of acid. So we know that if Ka is more than more H plus concentration, means more acidic. So here the Ka value of CH3COH is 1.7 into 10 raised to minus 5, and for HCN is 4.9 into 10 raised to minus 10. So this value is more. So Ka is more, means this is more acidic. So CH3COH is more acidic than HCl. So similarly, for base also we can check. So for base we can take for weak base. So MOH is going to give M plus OH minus. So equilibrium constant if we take, then concentration of product by concentration of reactants, and for base K equilibrium equal to Kv. So Kv equal to M plus OH minus and MOH. So Kv is directly proportional to OH minus concentrations. So if OH minus concentrations increases, means Kv will increases, means that is more basic. Whereas for if you search for strong base, like if we search NaOH, that will give Na plus OH minus, Na plus OH minus. So this is completely ionized. That like T equal to 0, this is 1 molar is there, this is 0 0, and when T equal to T equilibrium, this is wholly consumed and 1 molar H formed. So for this case, Kp is very large. Kp is very large. So we normally not used to take for strong acid or strong base. So similarly, if OH concentration is more, then Kb is more, and if Kb is more, then more basic. So if Kb value is given and asked compare the basic strength, so we can compare the same way as we compare for acidic. So more Ka value means more acidic, means more H plus. So I studied that Ka is more, then that is more acidic, and Kb value is more, means more basic, and less than less basic and less acidic. So this is for Ka values, and next we will study the Oswald's dilation law. So what this law says? This law says degree the degree of dissociation, that is you can say that is alpha, is directly proportional to the square root of extents of dilution. What it says that alpha is directly proportional to square root of extension of dilution, that is volume. Or he says that the degree of dissociation, that is alpha, is inversely proportional to the square root of the concentrations, that is. So m equal to molar constant n by b, and this we are taking m as c, so c equal to n by b, and for 1 moles c equal to 1 by b, that is c is indirectly proportional to b. So first he says that alpha, degree of dissociation, is directly proportional to square root of dilution, that is b. Dilution means how much volume, and since c equal to 1 by b, or we can say uh, b is b equal to, so this one we can write b equal to or b proportional to 1 by c. So instead of b I can write 1 by c, and this. So this is the what he defined. Okay, this is what he says. The degree of dissociation alpha is directly proportional to the square root of extents of dilutions. That is, alpha is directly proportional to the extensions of dilutions. That is volume. First he says, and we know that volume is directly proportional to concentration. So C equal to 1 by B. So instead of B, if you put the C, then this will become 1 by C. So that C says. So let's take for HS weak acid. So this is H plus A minus. Okay, and when T equal to initially, that is t equal to 0. This is C concentration is there, so 0 0. And when t equal to T equilibrium, then suppose C alpha has conjugate, then this C alpha will pop, C alpha will pop. Then usage, then what is the K equilibrium? Or for acids, that you can say Ka is equal to concentration of product, that is H plus, and concentrations of reactants, that is Ha. So put the value at equilibrium. What are the values? C alpha, C alpha, C minus C alpha. So if you do this, then how much? C alpha. I can say C 1 minus alpha. This cancel. The alpha square. No, two alphas are there. So this is going to be C alpha square 1 minus alpha. And what he says that for weak acids, for weak acids, alpha is very less, that is around 0.05. So if he says 1 minus 0.05, that is nearly equal to 1. So we just neglect this value. So if you neglect this value, then this is becomes C alpha square 1 minus alpha. So alpha is very very less, so we can take as 1. So this is equal to Ka. Yes, this is equal to Ka. This is equal to Ka. So Ka equal to C alpha square. Then C alpha square equal to Ka. Alpha square equal to Ka by C, and alpha will equal to Ka by C root over. So this is given by Oswald's law. Oswald dilution says that alpha is indirectly proportional to concentrations, or degree of dissociation is directly proportional to dilutions, a square root of dilutions, and indirectly proportional to square root of concentrations. So what dilution? Oswald's dilution says dilutions that degree of dissociations is Ka by C, this or this is. So this is for acids, and for base similar way if you would get, then alpha will become, so just put instead of Ka we will put Kb, same way we can get it. So for base, that is Kb by concentration. So but this is valid only for mono weak acid or mono weak basic. So this is the limitations of Oswald-Dilution's law. So this, if you calculate for diabasic and triabasics, for that case, if you put direct this formula, then answer will get wrong. So apply this formula only for monoacidic and monobasic. So we'll solve two problems related to this. So let's this example. So Ka is given, and this is monoacidic 1H plus. It will give, this will give CH3COH, CH3 CO minus plus H plus. So one acid is getting, so one H, this gives one H plus per molecule. So this is monoacidic. So for monoacidic and monobasic, we can use the Oswald dilution's law. So for this, so Ka is given this, and the concentration is given this. So you can easily calculate the value of alpha. So alpha equal to Ka concentration full root. So Ka is given 1.8 into 10 raised to minus 5, and our concentration is given 10 raised to minus 1. So just calculate 1.8 into 10 raised to minus 6. This is 1 by 2. So this value will be 1.8. That is, if you calculate 1.3 into this is 3, so minus 3. So alpha equal to 1.3 into 10 raised to minus 3. And they are also ask the concentration of H3O plus. Okay. So what it give? So that is CH3COH. CH3COH. This is going to give CH3CO minus plus H plus. So at T equal to 0, this is 1 molar is the concentration if we are taking. This is C, then this is 0, 0. And when T equal to T equilibrium, so C minus alpha H consumed, then this C alpha H formed, this is C alpha H formed. And they ask that concentration of H3O plus. So H plus and H3O plus are same. So I already explained why H plus we are not right. Practically we are getting H3O plus. So H plus and H3O plus is same. So they want to ask this value. So we know the alpha and we know the C. So C alpha H plus or H3O plus equal to C alpha. So C we know that is 0.1 and alpha we know 1.3 into 10 raised to minus 3. So this is equal to 10 raised to minus 1 into 1.3 into 10 raised to minus 3. That is become 1.3 into 10 raised to minus 4. So this is the value of alpha. Concentration of H plus. Similarly, another examples, if we say, so for this example, so Kv is given, Kv of for this weak base is this, and at 298 Kelvin, calculate concentration H3O plus in a solution having 2 molar concentration of H3O plus. Okay, so for this, so solution, so Kv is given, Kv is 1.6 into 10 raised to minus 8. Okay, and this is, so guys, so what happened? So this is not a mono basic, this is diabasic. So for diabasic, we cannot use Oswald's dilution law. So for this, what you will do? Just know that is this dissociate into what? M2 plus 2OH minus. So at T equal to 0, this is suppose concentration C, then nothing has fallen, and when T equal to T equilibrium, so C minus C alpha H conjugate, then this will form C alpha. So for 1 mole C alpha H consumed, then for 1 mole C alpha will form, and for 2 mole 2 C alpha will form. Okay, so what is the mole is given? According to that we have to write. So this is for 2 moles, then 2 alpha will form. Okay, so these things I already explained. So okay, so now they ask that calculate the concentration of H3O plus. So for this, Kb is concentration of product divided by concentration of reactants, K equilibrium. This is K equilibrium. So K equilibrium will be concentration of product divided by concentration of reactants. So concentration of product is this square and M2 plus, and this is MOH2. Okay, just oh sorry, this is T equal to T equilibrium. This is C minus alpha, this is C alpha, this is 2 C alpha. Okay, so they ask that concentration H3O plus, means they want to ask that, okay, they want to ask concentration of H3O plus. Okay. Hmm. Okay, so we know that Kb, we get the value Kb is equal to OH minus concentrations, that is square, and M2 plus concentration divided by MOH2. These concentrations and M2 plus concentrations. Okay, so they have given the Kb. They have given the Kb equal to 1.6 into 10 raised to minus 8. So just put 1.6 into 10 raised to, okay, you put later. So Kb, so OH is how much? So 2C alpha. So 2C alpha, so 2 times 2C alpha, and M plus concentrations HC alpha, and MOH concentration is C minus C alpha, C minus C alpha. So if you do it, M plus H, another is C alpha. So this is for OH, and this is 1 time, so C alpha. Okay, so if I do it, then 2C alpha into 2C alpha into C alpha, that is C1 minus alpha. So if I says that this C will cancel it, then how much are you getting? 2 to 4. 4 C square, how many alphas are there? 3 alphas. So alpha cube. This is 1 minus alpha. So this is for weak base. You know, weak base alpha is very less, very less. So we just neglect it. Then Kb is equal to 4 C square alpha cube. Okay. So you want to know the alpha cube, then just put Kb for C square. Then alpha cube equal Kb for C square. So alpha equal to Kb for C square, that is 1 by 3. So Kb value they have given, that is how much? 1.6 into 10 raised to minus 8. Okay, so 1.6 into 10 raised to minus 8. And for C value they given how much? C equal to 2 molar. So that is into 2 into 2. And this by 1 by 3. Okay. So if I take this, then if I take out this point, then I can add into 10 raised to minus 9. Okay, and this is 4 to 8, 8 to just 16. This is 1 by 3. So this value will be cut, then this is 10 raised to minus 3. So alpha equal to 10 raised to minus 3. And what they ask? They ask the concentration of H2 plus. So this is concentration of OH minus. Because for H3O plus we have to know another, that is Kw. So that we will study after this. After that we will calculate H3O plus also. So for now we will only calculate the concentration of OH minus. So OH minus will be 2C alpha. So we get the alpha equal to 10 raised to minus 3. Then OH minus concentration we want to calculate, that is 2 C alpha. So 2 and concentration is 2 molar. So into 2 into 10 raised to minus 3. Alpha value is 10 raised to minus 3. That is 4 into 10 raised to minus 3. So this will be the answer. This will be the answer that is OH minus concentration. So and for H3O plus concentrations, we will for next after some times we are going to study that is Kw. After calculating Kw, we will calculate the concentration of H3O plus also. For time being, we only calculate OH minus concentrations. Okay, so we have studied that Oswald's law is only you will apply where that is monoacidic or monobasic cases, and if it's diabasic and tribasic, then just calculate that just do dissociation. After that, we use that how we are using for equilibrium constant. So similarly, we can calculate. So for monoacidic and monobasic, just apply the formula that is K for acid alpha equal to Ka by concentration, and for this is for base acid, and for base that is equal to Kb by C or monoacidic or monobasic. Okay, so next we are going to study so next term will be Kw. So we will we will study the dissociation constant of water. So dissociation constant of water. For the dissociation of water, we have to give the heat. We have to give the heat. So if heat is given, then delta H is positive. Okay. So next. So like if we say that for HCl, so dissociation constant of water. So what I said, like this is H2O. So this will dissociate into H plus OH minus. Okay. Also you can say H2O plus H2O will give, then this will give us H3O plus. Why I am taking two water? Because we say I already said that H plus is not exist because this is very less mass, so very less size, and again plus positive charge is there, so it will attract water, lone pair of water, and what will become, this will become H3O plus. So one molecule of water is taken by H plus to become H3O plus. So we are taking 2 moles of water to get one is H3O plus, another for OH minus. So for this, K equilibrium will be concentration of product by concentration of product by concentration of reactants, that is 2H2O. Okay, and K equilibrium is for our case. So okay, so you will take this K equilibrium H2O concentration, that is equal to H3O plus and OH minus. So that is K equilibrium into H2O, that is H3O plus OH minus. Yes. So this value I take as constant because K equilibrium is already constant and dissociation of water is taking, so that we say Kw. So Kw equal to H3O plus OH minus. And what we know that Kw is constant at given temperature. So this value at room temperature, that is practically get that Kw equal to 10 raised to minus 14 at 298 Kelvin or 25 degrees centigrade. So what is H? So Kw equal to concentrations of OH minus and concentration of H3O plus concentration, and also it says Kw equal to 10 raised to minus 14 at 298 Kelvin or 25 degrees centigrade. So that is Kw equal to that I says Kw or OH minus concentrations and H3O plus concentrations equal to 10 raised to minus 14. Okay. So since this value is constant and uh, at neutral, what I says at neutral, what H plus, we can say H3O plus equal to OH minus, because at neutral it is neither acidic neither basic. So at neutral, this value and this value is same. So suppose this value, this concentration is x molar, then this is also x molar at neutral. That is equal to 10 raised to minus 14. So 10 raised to minus 14 equal to x square. Okay. So 10 raised to minus 14, this is for x, we can write this is 1 by 2. So that is x equal to 10 raised to minus 7. Okay. So x equal to 10 raised to minus 7. Okay, so x equal to 10 raised to minus 7. So at neutral, so Kw equal to OH minus concentrations equal to H3O plus concentrations, and that is equal to 10 raised to minus 7. And at basic medium, at basic means what? Basic means OH minus concentration is more than H plus concentration. So OH minus concentration more than H plus concentration. At neutral, this is the H plus and OH minus concentration is this amount. So at basic OH minus concentration is more, means OH minus concentration is more than 10 raised to minus 7. Okay, so that means H plus is, that is for H plus is, H plus are equal to H plus can be 10 raised to minus 8, 10 raised to minus 9, 10 raised to minus 10. And similarly at acidic, H plus concentrations is more than OH minus concentrations. And at neutral, we know that at neutral, H plus or OH minus equal to 10 raised to minus 7. So at acidic, since OH minus H plus concentration is more, means H plus concentration is more than 10 raised to minus 7. Neutral means acidic means more than neutral, and basic means more than a neutral value. So for acidic, H plus will more than this neutral value 10 raised to minus 7. So H plus concentrations can be more than 10 raised to minus 7 is like 10 raised to minus 6, 10 raised to minus 5, 10 raised to minus 4, etc. Okay, and so these are the value. And what I says that dissociation constant of water for this heat has to be given means delta H is positive. So we know that like for equilibrium constant, if delta H is positive, then if T increases, then K equilibrium also increases. Okay, and for if delta H is negative, then T increases, then K equilibrium will decreases. And if delta H is 0, then if you increase T or decrease T, K equilibrium will constant. So we studied this in chemical equilibrium. So our dissociation of constant of water, dissociation of water is actually endothermic reaction because delta H is positive. So if delta H is positive, then if we increase the temperature, then K equilibrium or K dissociation constant of water is increases. Or if we decrease the temperature, then this Kw value will be decreases. Okay. So if I says that Kw is equal to 10 raised to minus 14 at 298 Kelvin. And suppose if we say, if you decrease the value or if you increase the value, like I will say 400 Kelvin, then this value also increases. Then it may become 10 raised to minus 12 or minus 10, something like that. So if you increase this, then this also increases because this is endothermic reaction, because dissociation constant heat is needed. So heat is needed means it is endothermic reactions, and for endothermic reactions we know that if heat increases, if temperature increases, then Kw also increases. If that heat is releasing on this case, then if we increase the temperature, then Kw will decreases. But dissociation of water, we need heat. That need heat means this is endothermic reaction. So if you increase the temperature, then Kw also increases. So this value is only at 298 Kelvin. So if you increase the temperature, then this value also increases. So one example is related to this.